So here's our first dedicated set example, and we are going to go back to another control flow. We've got if a greater than 0, return 1, else return 0. So compiling that at optimization level 2 gives us this, but I'm just going to tell you that set greater than 0 is a pseudo instruction. So set greater than 0 would be the notion of you have a source, and if the source is greater than 0 per a signed comparison, set the destination to 1, and otherwise set the destination to 0. But it's a vicious pseudo-assembly instruction, and we don't want to see that kind of thing because it's actually a salt instruction with a hard-coded x0 as its source 1. So let's go ahead and get rid of that vicious pseudo-assembly instruction and see the salt that lays beneath. So new assembly, salt, set if less than, and this is going to be a signed comparison, unlike the salt u, which was an unsigned comparison. Again, same sort of principles as other assembly instructions, tacking on u's for unsigned, tacking on i's for immediates, tacking on w's for word-sized things. So salt, source 1, source 2. If source 1 is less than source 2, and that's treated as a signed comparison, so they could be interpreted as negative numbers if appropriate. So if the source 1 is less than source 2, set the destination register to 1, else set the destination register to 0. So if the set greater than 0 is a salt with a hard-coded x0 for the source register, then you'd see that it would be doing a 0 if 0 is less than your value. And so that would only be set when you have positive values for RS2, right? So set greater than, these would have to be positive values greater than 0 because that would not hold for a negative value. If RS2 is treated as signed and it was like a -1, well, -1 is not greater than 0. Okay, well, once again, stop, step through the assembly, and make sure you understand how this optimized code is using the set greater than 0 or the salt in order to optimize down this comparison of a greater than 0.